Hello guys, this is a tutorial for the V gutter for the afterburner. So let us start with the domain creation. So first we have what we have decided, we will create the three domains. First the innermost weak region, then the outer one and the outermost one. We have created three regions because we want the mesh to be uniform so that the transition is smooth and we got the good numerical results. So let's start with the first one. We will create sketches. Here is the sketch option. Go to sketching option here. We'll create a rectangle. So let's create first the most innermost one. This is the innermost region. Now we will go to the constraints so that we can give it the symmetrical. Here it is now symmetrical. Now we will fix the dimensions. This is the horizontal option that help us to give the horizontal distance. So the extrude distance is 5.71 as per our design. Oh, since we have not taken the dimensions in mm, let us take it in mm. Okay. Sorry. Yeah. S3 is 5.71. S2 is 150. And the V1 is 50. Okay, so we are done with our innermost domain. Now we will create the outer one, but with a separate sketch. We go to sketching again. Do the same thing for it. Give the constraints. It is symmetrical now. Now we'll give the dimensions. So V4 is 70 and H5 is we'll just calculating what it is. Just a minute, let me calculate. Yeah, this is 278.5 mm. Now set the horizontal distance between the two wake regions. It is 10 mm at 6. So we are done with this sketch now. Now the outermost one. Another sketch we will draw in the XY plane. Go to sketching again. Do the same for this. Okay, so now we have created the outermost domain. Now let's give the dimension. So distance between the outer one and the most outer one is 50 mm. We have given that. And the height is takes up 105 mm. So now we are done with this sketching. Now what we have to do is next to create surfaces from these sketches. So you go to the concept and draw surface from sketches. Select the sketch one, draw the surface. Don't forget to change the add material to add frozen. It will help you to see through the images. Okay, we have created the another surface. Now go to the surface from sketches again for another and repeat the same. Okay, so now we have created the three surfaces. But when you go to the meshing, you will realize that the meshing in the three zones will intersect. So because these surfaces are overlapping. So now what we have to do is uh, change the overlapping. We have to create the three separate zones, independent zones. So I will do is I will remove one surface, boolean out the one surface from the outer one. So let's start with the most outer one. First go to the create, choose boolean, change it from to subtract. The target bodies from which we have to subtract. So the outermost one is the target body. Tool bodies what we are subtracting from the inner one. So we are subtracting the outer body, outermost from the outer body, the inner body. the linear body. Okay, we have subtracted it. Now you go to this option, you will see that it is still same. Means that we have done something wrong. We will go to the edit selection again, select the tool body carefully. Now it is correct. Now this region is gone and we got the different zone, a separate zone, which will not overlap with the inner zones. We will do the now what we have to do is go to this surface from sketches again. I will again create the sketch surface from this, and this will be independent from the outer one. And I will do the same procedure for subtracting the innermost from this newly created surface. Go to create boolean again. Now this time the target body is this one, and the tool body is the most inner one. Now this has gone. We got now two surfaces that are independent of each other. Now again go to the surface from sketches I mean. Okay, add frozen, surface is created. So now we got three independent surfaces. This, this and this. They are non-overlapping. Now again go to boolean and subtract the V gutter. Here the target body is the inner one, tool body is the V gutter, and at voila we are done. See, this has been subtracted out. Now, yeah, one important thing. See, you can see these are the three different parts. So when you go to the setup, it will it will create these different bodies and treat them like wall. So to avoid this mistake, you go to you choose these three surface bodies and create them a one part. Right click and form one new part. Now that will not cause that problem. Now let us go to the meshing part. It will take some time to open. In the meantime, go have some coffee. Okay, so now let's start with the meshing. We will do it very fast. We will choose the innermost surface. Give the sizing help us to give the element size as per our convenience. So our most region of importance is the innermost region, wake region. We want the finer mesh here. We will what we have decided to use the 0.5 mm here. So let's change the matrices to kgs. Okay, go to the sizing, use size. I have created 0.5 mm here. That is done. Now do the same for the second region. Face selected, given it 0.75 for the smooth transition of the mesh. 0.75. Sizing, outermost region, element size 1 mm. Okay, now important part is inflation also. We have to provide the inflation to capture the resolve the boundary layer appropriately. So in geometry, we will choose all three bodies over which we have to create the inflations, and the boundary is the boundary is where we have to create the inflations. So best way to choose the boundaries is the box select. It should show around 6 bodies, not more than that. If it's showing more, then it will be a problem. It's good. We'll provide 12 maximum layer, and instead of smooth transition, we will use first layer thickness to maintain the y plus values. 0.01 is what we have decided, but you can choose as per your y plus values. There are all y plus value calculators online, so you can choose according to your convenient. And if you don't have much good computational power, you can also create the wall boundary functions. We will take a separate video regarding that. For now, let's update the mesh. So guys, we are done with meshing now. So as you can see, we got the three regions. The most innermost is the most finest one, and the outer region is the other region, and so the first region, as you can see, the most region is the most finest one, and then the second region is the a little bit more coarse, and the outer region is the most coarse one. So as you can see, the mesh transition is quite smooth, and you can also use unstructured mesh. There is nothing wrong with that. And let's us check the boundary layer thickness, and so the boundary layer inflation, or we can say inflation. You can see there the inflation is made quite well. We got the 12 layers as we have said. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So it's fine now. Now let's give name selection so that the NG student setup can automatically perceive what we are trying to give the boundary conditions. Go to S selection, choose it as inlet. Done. And this is our pressure outlet. I will name it as outlet. You can name rest of the regions like this and that, but it will automatically treat them like wall if you don't give any name selection as well. So I will leave them as they are. Now update your mesh, show that so that the information from the mesh transfers to the setup. Here you can choose select the number of cores. It is basically proportional to your computational power. As per your resources, you can choose any number of cores, but here I am choosing the 5 cores because we are doing the 2D mesh and we don't require much cores. It will take some time to load. Now it has been loaded. As you can see, as I have told you earlier, that name selection helps ANSYS to perceive what we are trying to give the boundary conditions. Like it has automatically detected the inlet, the blue arrows, and the outlet from which is shown with the red arrows. So we go to general. We are using pressure based steady simulation planar absolute. We are not using gravity here because its effect is very much low and it is quite neglected. Okay, so you can display whatever you want to see here. These are the scales you want to scale down, scale up as per your convenient. So yeah, it is one of the most important thing since we are using we are capturing the flow around the solid. We are actually studying solid fluid interaction. For solid fluid interaction, the most suitable methods are uh, uh, K omega SST and K epsilon. So basically, K omega SST uses two equation and K epsilon also uses two equation. However, K epsilon uh, is usually used this is usually used to capture the flow very much above the upstream means not near the solid. But if you have to resolve the flow near the solid and you have to study the solid fluid interaction, then you must choose K omega SST. K epsilon is also fine, but K omega SST will give you good results. And there are also other methods like Spellert LMRs, which uses one equation. It is simple method, it will give you results and show convergence fast, but it will be not as precise as these ones since they are using two equations. Then they are laminar invasive. Since we are studying the turbulence or the swirl which is created by the begetter in the afterburner, we will not choose laminar. Okay, we will choose K omega SST, yeah, K omega SST, and leave everything as they are set. You can use LES as well. However, don't have much computational power with us, so we will not choose LES for these cases. K omega is quite fine. Okay, then go to boundary conditions. Inlet, we are given the inlet. It is automatically rated to velocity inlet. So velocity we have chooses 8.2 meter per second, which is absolute. Okay. You can see outlet, pressure outlet, gauge pressure 0, which we wanted as per our requirements. Other things it has set automatically as wall and interior. So we will leave them as they are. Yeah, here we have monitors. You can set the residuals. So usually the residuals we choose for continued 10 to the power minus 3, and for rest 10 to the power 6 you can 10 to the power minus 6 you can choose. So I have set the residuals and click OK. Now go to the initialization. So what initialization does is solves on it solves 10 iteration and so if the hybridization initialization is done or not. You can do standard initialization, but however, hybrid initialization assumes the standard values over your domains and give good convergence. Now run calculation. We will use 1000 calculation as for 2D cases. 1000 calculation are more than enough, and the result will be converged before that. But if you are doing in 3D or more complex modeling, turbulence modeling, then you will need a much more number of iterations. Then we will do calculate and we will wait. Okay, so now the calculation has been started. See, as you can see, the residuals is are converging, they are decreasing, which is a good sign that our solution is converging. As you can see, our calculation is completed. We are good to go. Our residuals has been converged so smoothly. I'm happy. Now let's go to graphics. From here, you can plot contour, vectors, and path line. You go there, you choose the parameter you want the contour for. We go to velocity. We choose what we want to show here, over which we have to plot the contour. As you can see, we got our contour. So if you choose inlet, inlet will be shown. If you choose outlet, outlet will be shown. If you choose symmetry wall, that will be shown. And the velocity over it will be shown. Okay. So we got the contour. We can also plot the pressure contour. We can plot XY plot. I will leave up to you that up to what you want to visualize. Now go to post processing. Now we will go to post processing. So we have entered in the post processing. Here you can select what you want the window to be what you want to see. Okay, in the location you can plot points, point clouds, lines, planes. So we want to plot the contours, streamlines, and whatever we want to visualize on a plane. Since it is a 2D, I will create one plane. Okay, in the XY plane we have created. Okay, now let's visualize the velocity flow using streamlines. Here it is streamlines here. Since it is 2D surface streamlines, we will choose or 3D. We can choose because this is 2D. It is a almost like 3D with very small thickness. So we can go with that, or you can choose 3D, 2D. Everything is fine. So start from, it will ask from start from. You will choose inlet. Means we have to start it from inlet. Or we can choose plane one because we want to plot it here. And we will choose face center. Now let's wait. Yeah. Yeah. So on the plane one, we have created the streamlines. You can also increase the streamlines using the maximum point here. Like previously, we have use 25. Now I'm using 50. You can use equally spaced samples. However, I was interested in the vorticity study in the middle region, so I have used space center here, as you can see. So we are done with that. We can plot contours here as well. I go to inlet pressure. We want to plot the velocity contour. I have chosen velocity. Location, I will choose plane 1 because I want to plot that on one plane. You can see we got the velocity contour, which is looking quite good. Also, for playing purposes, to use your visualization power, you can also do render your plots. Like I will choose this plane like this. Plane is become black in background now. So if you go to streamline again and plot it again, and you have to deselect this to see that. Uh, Look how now nice it is looking. So I was just playing with that. You can do this as well. Yeah, then one of the most important thing is vortex core region. Since we are studying the vorticity created due to V-Gata's different designs, we will go to the vortex core region. We will choose the vorticity. Here you can see different values. So basically, if you have to study the vortices swirl generation and you have to quantize them to see their nature, you can use different methods like Q criteria or lambda 2 criteria. So basically, what the Q criteria is, basically criteria is half into uh, modulus of rotation square minus speed square, or the normal flow square, stream velocity square. If your rotation is significant or it is a dominant one, then your Q value will be greater than 1. I will show you right now. I will deselect the streamline and let's give it some different color. Let's say red. Okay. So as you can see, basically it is shown in 3D. Apply. Color I have not chosen. Color. You can choose whatever color you like. Girls like pink. I also like pink. So yeah, here we are. As you can see, the Q value is greater than 1. Means it's positive, I mean. So it means there are vortices there. Means the where the rotation is significant than the normal laminar speeds, as you can say. Okay, so as you can see level here, you at different levels you can see different ranges. If I decrease the level, let's say 0. Or I can decrease level, let's say 0.001, you will see it they have been enlarged. So basically level is what? It is a threshold. If you keep the threshold very low, then you will see that the vortex region or the wake region will become very broad. So basically, then the very weak swells or the very weak vortices, very weak rotational, region will also be appeared. So you can choose as per your convenience. If you choose very large, then only very strong vortices will be captured. If you use very low, then almost most of the vortices will be captured. Weak one as well. If you want to study the very core one, which is the major core region of vortices, you should keep it high. You can study the different ranges of these threshold values online if you want to dig deeper into it. But for now, I will choose 0.001 and I will compare all values on this only. Okay. So we are done with the post processing and I will take a leave. Bye. In the meantime, explore CFD and follow my channel.